Still a really good tool today. All right, now we've stepped up into meal dot reticles. Again, we have the heavy duplex, and the heavy duplex at low light actually helps us sometimes see exactly what we're aiming at. The crosshairs, if you're not utilizing illuminated reticles, a lot of times the crosshairs kind of get to where they get washed out and we can't see them. So the heavy duplexes really kind of help us pick up what we're aiming at the time when there's no light. All right, same thing with this. What I decided to do, instead of using a lot of max point blank like we did in the past, or running 500 meter hold over, hold under drills, what we ended up doing was actually zeroing here at 100 meters. All right, if you're working with a meal type turret, you can actually dial 5 meals up and put your 100 meter zero up here at the top duplex. All right, what this gives us, if you're working with a TMOA scope, it's 17.2 minutes of angle equals the 5 meals. So if you're running either one, you're going to have to dial. If you're dealing with minutes of angle, you may only have 17 minutes is all you can dial. If you're in a quarter minute, you can dial 17.25. All right, but that gives us the same thing to where we're zeroed up here at the top. Now what this does, instead of doing like a 500 meter hold over, hold under drill, all right, or having a 300 meter zero on your gun and you're actually, up in the top portion with your crosshairs for 100 meter, not your crosshair, but your actual hold. This allows us not to have to do math because that's what it's all made for. So basically what we call this is a poor man's horse. The poor man's horse allows you now, if I'm looking at a target and I say it's 305 meters, I know my mill hole's 1.5, I'm going to put it right here. It's 1.5 mils down from the top. I know if I'm going to shoot 400 meters, it's 2.4. So I'm going to hold here. This would be 305. This would be 400. All right, if I know my holes for 600 is 5 mils, this equals 600. All right, so right now, very quickly, if I already have my dope sheet in my scope cap cover on the side of my gun, or I've memorized my holes every 100 meters out, very quickly, if I say, hey, I got a target at 780 meters, my hole's 8.2, all I have to do is look down and go to 8.2 and hold. So it's a very refined way to do this. Now, the problem that you're going to run into is when you start getting out here on wing calls. All right, because holding out in space, and that's one of the huge benefits of the horse reticle, is that we always have a refined aiming reference point with the horse reticle. When you're holding out here in space, for one, it's hard to actually know exactly how much you're holding out. The other problem is when you actually think you're holding here and your bullet impacts here, you break that shot, you fall back down under recoil. The next thing you're going to see is, all right, I see the puff of smoke, or I missed my target, now where do I make my adjustment? You don't have any good measurement to go off of. It's not very quick. So a lot of times we have the guys actually go ahead and dial their wind if the wind's blowing like it does out here. So usually, I never tell the guys to ever dial wind. All right, we always hold for wind because things change. In a tactical environment, you may have a mover and you're holding, 2 mils for a 4 mile an hour mover, or 2.2, and you also have wind. So you're holding for both of them. But if that target actually turns around and moves the other way, now you have to start taking it off. And if you've actually dialed it on, now you're reaching up there and jerking stuff off, and it's slow. And if the target's moving left and right, it's kind of ridiculous to be dialing. For right now, we're just doing pure holes. This is the only time I actually tell guys go ahead and dial for wind, is when we're actually using a poor man's horse like this. It's still a mill-based system. All right, so we can still use it when we're doing mill relation formulas to figure out how far away the target is. You can actually take the size of the target. If the target's 12 inches, divide it by what you mill it. If you mill the target at 0.8 mils from here to about here, if the target mills that size, the target's 381 meters away. All right, so you can utilize that by going 12 divided by 0.8 mils. All right, once you do that, times 25.4 will give you 381. Now, if you're working in yards, you'd times 27.778. All right, so you can still utilize this the same way it was meant to be utilized. This is just a more refined method of utilizing a standard duplex. All we did is start adding in dots all the way through. All right, now, once we went from this, a lot of guys started going...
Quick question for you, Todd.
Yep, go ahead.
Before you take that down, how do you find the system works out with using a more traditional mill dot system like the old oval-shaped USMC mill dots?
I really didn't like the oval. They were 0.25 tall. This is actually pretty good because you can actually take and refine it a little bit. All right, we'll make them a little bit larger. In some of the better systems, mill dots, there's a lot of different types of mill dots. Some have half mil subtension marks like this, all right? And then once you get out here, all right, some reticles actually look like this where there's 0.2 subtensions, all right? This is on left, right, top, and bottom, all right? So again, it's a good way to actually mill a target out. Anytime it is subtended more, what you're going to find is you can actually more accurately mill that target. Instead of looking in here and going, I don't know, the target's from here to here. All right, well, that's a little over a half. It may be 0.6, maybe 0.65. I don't think it's 0.7 yet, but we're guessing. We're trying to extrapolate, and that's the problem right now. So when we actually changed the reticles and we gave them half mil marks, all right, it made it much easier to actually guess and actually kind of figure out what the mills were. So if that target was milling from here all the way to there, now it's a little bit easier to see that's probably closer to 0.7 right there. All right, so our eyes can break it up a little bit easier, all right? But as we go through and we start talking about the horse reticle in a minute, you're going to see it's real easy to refine your milling to where you can very accurately get a range estimation. All right, the next reticle that we really